Alright, today's lesson is going to be on 6.3, solving multi-step inequalities. When you solve a multi-step inequality, it's no different than the inequalities that we've been solving, except now you have multiple steps to it, just like multi-step equations. So you're just going to solve this exactly like you'd solve an equation. The only difference being now you have a greater than, less than or equal, or greater than or equal sign. So for this first problem here, you've got 3y minus 7 less than 8. First step is going to add 7 to each side. So you get 3y less than 15. Second step will be to divide by 3. And you'll end up with y less than 5. Now that you've solved the inequality, what you're going to do now is you're going to write the corresponding interval notation. So y is less than 5. That means 5 is the largest. Cannot equal 5. Negative infinity is the smallest that you could be, so you're going from negative infinity to 5. Then you want to draw the number line. So if we mark 5 on the number line, we've got an open dot at 5, shaded to the left. And then finally, because the variable is a y, we're going to make the graph. We're going to mark it at 5 on the y-axis. Because it's the variable y, we're going to make a horizontal line. It's going to be dashed. And because y has to be less than 5, we're going to shade underneath. Now let's look at the second problem. In this one we've got a decimal. Nothing's going to change though. We're going to do the exact same thing. So negative 0.6, we've got to distribute inside. So we're going to distribute to each term here. That gives you negative 0.6 x. Negative is a positive. 0.6 times 5, you plug that in your calculator, that would give you a 3. Less than or equal to 15. Now we're going to subtract 3 from both sides, trying to isolate the variable. So you get negative 0.6 x less than or equal to 12. And now we're going to divide by negative 0.6. Now notice we're dividing by negative. From the last section when we divide by negative, multiply or divide by negative, we're going to flip the sign. So x, you flip the sign, is now greater than or equal to 12 divided by negative 0.6. If I plug that in my calculator, it gives me negative 20. So x has to be greater than or equal to negative 20. Now we need to make the corresponding interval. So greater than or equal to negative 20, that means negative 20 is the least. It could be equal. It's going up to infinity. Then we're going to make the number line. Negative 20, mark it. We've got a closed dot shaded to the right. And then because we have an x variable here, we're going to draw the number line, or the coordinate plane. X means we got a vertical line at negative 20, so let's mark negative 20 out here. Vertical line that is bold because it could be equal, and we're going to shade it to the right because it's greater than negative 20. Shading to the right. Now we have a problem that has variables on both sides. So if you remember when we solve equations with variables on both sides, we want to get the variables on the same side, the numbers on the same side, opposite of each other. So in this situation, I've got 6y on this side and 2y on this side. I'm going to subtract 2y from both sides so that I combine the y's on one side. That's going to cancel. 6y minus 2y is 4y. Minus 7 greater than 17. Now we're going to add 7 to both sides. We get 4y greater than 24. And divide by 4 on both sides. So y is going to be greater than 6. If y is greater than 6, the corresponding notation should be, well, that means 6 is the smallest, so 6 to infinity. It can't equal 6. Cannot equal infinity. Draw the number line. We're going to mark 6 on the number line. We have an open dot. Greater than 6 means going to the right. And because we're using the y variable now, we're going to draw the coordinate plane. Variable y tells us we have a horizontal line at y equals 6. So go up to 6, mark it. This is 6. We've got a dashed line at 6, horizontal. And y is greater than 6, so we're going to shade above where the solutions are, bigger than 6. Now we have two different examples here that are going to be special cases. Alright? We're just going to solve these like normal, but you'll see that they turn out to be a little bit different than what we've seen. We've got parentheses here, so we need to distribute. We get 7 times 2x, that's 14x, minus 21. Sign still stays the same, greater than 14x plus 5. You should start to see, right now you should start to see that, oh, we have 14x on both sides. You can start to see that there's something, a difference going to happen here. So let's combine the x's by subtracting 14x from both sides. Well, guess what happens? The variables cancel out and you don't have any more variables. You just left with 5 less than negative 21. Well, your whole goal was to solve for what the variable x was, but because it canceled out now, it's telling you 5 is less than negative 21. Well, you have to ask yourself, is 5 less than negative 21? 5 is not less than negative 21, so that means that this can't happen, which means that this whole thing here can't be equal. All right? This 14x plus 5 is never going to be less than 14x minus 21, which kind of makes sense. You have two things that are the same, 14x. If you add 5 to one of them, but you subtract 21 from the other one, they're never going to be, this one that's plus 5 will never be less than the negative 21. This one would be less than. So in this situation, because 5 is less than, or is not less than negative 21, because this is not true, this would be a no solution problem. So anytime the variables cancel out and what you get is not true, so the inequality that you get is not true, that's a no solution, because that's just telling you that the variables, no matter what you plug in for x, that the sides are not going to, or the inequality is not going to come out to be true. Let's look at the second case. We got parentheses again, we're going to distribute. You get 12x minus 6. You have 12x minus 1, and we still have the greater than sign. And notice, we have 12x and 12x on the same side. We're subtracting 1 on this side, but we're subtracting 6 on this side. Alright, and it says that the left side has to be greater than. Well, let's subtract 12x from both sides. When we do that, they cancel out there, so we end up with negative 1 greater than negative 6. Is negative 1 greater than negative 6? Yes, it is. Alright, so this is infinite solutions, or all reals. Alright, so we could just write here all reals. And that would be the answer to this problem here. Now, let's go back to this right here, this line here. It says 12x, 12 of something minus 1 is greater than 12 of the same thing minus 6. Well, that makes sense. If you're only subtracting 1 from 12x's, but you subtract 6 from 12x's here, obviously when you subtract 1, that's going to be greater than. So no matter what you plug in for x, because you're still multiplying by 12, anything can go in for x and will work. So this is an all real solution. That means x could be negative infinity to infinity, basically. Alright, it could be anything. So let's go ahead and write for this one here. There is no solution set here. For this one here, the interval would be negative infinity to infinity. And you should write that down so that you can tell that this is all reals. The solutions are from negative infinity to infinity. Don't forget to do the U-try problems.